Hello everyone, and welcome back to yet another Brainblitz Audio's production. We are at that time of the year again, the time when the Nobel Prizes are announced to the world. The 2025 Nobel Prize in Chemistry has been awarded to Susumu Kitagawa, Richard Robson, and Omar Yaghi for their work on metal organic frameworks. Their research has led to the development of a new type of molecular architecture with wide-ranging practical applications. Metal organic frameworks, or MOFs for short. At first, that name might sound complicated, but no, don't worry. The idea behind it is surprisingly elegant. Imagine a sponge, one that's so small you can't see it, but inside it has an enormous amount of empty space. That's what an MOF is, a tiny crystalline sponge made up of metal atoms connected by organic linkers, forming an incredibly porous structure with lots of internal rooms and hallways. What makes MOFs special is that scientists can design them almost like building with Lego blocks. By choosing different metals and linkers, they can control the shape and size of the pores, the little holes inside the structure. And that means they can decide what molecules can fit in, be trapped, or be transported through them. So why does this matter? Because these frameworks can capture, store, and transport gases and chemicals in ways no other material can. For example, MOFs can store hydrogen or methane, helping create cleaner fuels. They can trap carbon dioxide from factory emissions, helping fight climate change. Some even work like filters, purifying air or water, or like tiny delivery systems that carry drugs to precise locations inside the human body. The story of MOFs began in the 1990s, when researchers discovered how to create these intricate networks. Over the years, scientists refined the design, making these structures more stable, more flexible, and more useful in real-world applications. Today, MOFs represent a new frontier in materials chemistry, offering tools for a more sustainable, cleaner, and efficient future. The Nobel Committee celebrates this achievement not just for its scientific brilliance, but also for its vision, showing how creativity at the molecular level can help solve some of humanity's biggest challenges. Looking ahead, MOFs could soon be part of our everyday lives. They may power the next generation of hydrogen cars by storing fuel safely and efficiently. They could be built into smart clothing that captures moisture from the air to make clean drinking water in dry regions. MOFs might even help create more efficient batteries or be used in homes and cities to filter pollution and improve air quality. The possibilities are vast. By controlling the size and shape of the MOF components, chemists can design tens of thousands of different materials tailored for specific purposes, driving new solutions for environmental and energy issues. And this discovery shows how chemistry can shape a cleaner, smarter, and more sustainable world for all of us. Metal organic frameworks remind us that sometimes the smallest structures can make the biggest difference. By giving us a way to shape matter at the atomic scale, MOFs open doors to technologies that once belonged to science fiction. And now, thanks to this Nobel-winning research, they are becoming science fact.